Hello. I was just reading my favorite book, Vector Mechanics for Engineers. Now, this is UCF Stadium that I'm standing in front of. For years, students have waited for the stadium to come on campus so that they don't have to drive in hours of traffic to get to the Citrus Bowl. But no one could have predicted what was going to happen next.
Zombies!
Now, when the engineers designed this stadium, they designed it so it could support the weight of about 65,000 people, plus the factor of safety they took into account. But they never took into account the zombie factor.
In order to calculate the total weight pushing down the stadium, we have to have the sum of the individual weights. Now, we assume that the individual weight of a person in the stadium is roughly 170 pounds. From there, we know that the stadium seats 65,000 people. So if we calculate the number of the individual weights times the number of people in the stadium, we get the total weight to be roughly 11.05 times 10 to the 6th pounds.
Now, the force from just standing still on something is different than the force if you jump up in the air and land back on it. You've got to calculate the impulsive force.
Alright, so now we learned from our dynamics class, in which I love.
Me too.
Me too.
That the momentum equation is equal to the sum of the initial mass times the initial velocity plus an average force times the change in time is equal to the sum of the final mass times the final velocity. Here in this equation, we assume that the initial velocity is the velocity right before impact, and that the final velocity is right after we land. Therefore, we can assume that the final velocity is equal to 0. Rearranging this equation, we get the sum, the initial mass, times the initial velocity over delta t is equal to the force. Now, we could put a negative here, but it doesn't really matter to this equation. We have to find out what the initial velocity is. We can use simple kinematics. Bi is equal to V naught plus G times T. Since V naught is 0, Bi is equal to GT. From here, we substitute it into the equation. And now it's time to calculate it. This t right here is the time that you are in the air, which we assume to be about 0.2 seconds. This delta t is the time that it takes to land, which is about 0.1 seconds. From here, the sum of the initial masses times gravity is equal to the weight in which we previously calculated. That will give us the force is roughly equal to about 2 times the weight. 11.05 times 10 to the 6th power. to the 6th power, which will give us 22.1 times 10 to the 6th pounds.
Now, if I take this egg and place it on Aaron's head, nothing happens. But if I drop it from up here,
The egg breaks.